So this is actually like a second video to this section 0.2, real numbers. Now, we already discussed natural numbers, whole numbers, integers, rational numbers on the previous video. On this one, what we're going to do is move on to this bottom part of our handout and explain all these different things, like comparing numbers. First of all, we need to understand a number line, and we need to understand that anything that's on the left side is going to be less. Anything that's on the right side is going to be greater. That's right. I said great instead of right. That's just to help you out. Great means greater. Anything on the right side is greater. Anything on the left side is less, right? So if you compare any two numbers, like let's say -4 and -2. So if I have a -2 and a -4, and I ask you, which one's greater? Which one's bigger? Well, the -2 is greater. And why is that? Because when you compare the -4 and the -2, the -2 is on the right side, the -4 is on the left side. So anything on the right side is greater, anything on the left side is less. So that's how you compare numbers. Now, in order to compare numbers, you need to be able to understand the inequality, or the appropriate inequality to put between the numbers when you're comparing them. So this symbol means less than, this symbol means greater than. The best way to remember that is, remember this: the inequality is hungry and wants to eat the bigger value. So when you compare -10 and -9, well, it's hungry, it wants to eat the bigger value. Now some people might be thinking, wait a minute, isn't 10 bigger than 9? Well, again, to compare numbers, you should think about this number line and see which one lands on the left, which one lands on the right side. So if we go to -10 and -9, that's going to be way over here somewhere. And let's say here's -10, here's -9. So which one is on the right side? Oh, the -9 is on the right side, which means that the -9 is greater. So if you did have the comparison of -9 and -10, the inequality, it's hungry, it wants to eat the greater value. And we just said -9 is on the right side, so -9 is greater, so it has to open up to that -9 value. Okay. So these inequalities, piece of cake, it wants to open up to the bigger value. But in order to really understand which one's the greater value, is -10 greater or is -9 greater, you have to think about the number line and see which one's on the right side. Oh, -9's on the right side. That's why it has to open up to the -9. And that's why right here it's opening up to the -9. The greater value, it always wants to eat the greater value. Let's go to this next comparison, 5 and -2. Well, if we go to the number line for 5 and -2, let me do them in blue here this time. Here's -2. Here's 5. Obviously, the 5 is greater because it's on the right. The -2 is less because it's on the left. Okay, so it has to open up to the greater number, and that's exactly why it's opening up to the 5. Piece of cake. Okay, let's move on. Number 3, or section 3 right here. Converting a fraction to a decimal to a percent. Okay, so let's first just come up with any regular fraction. Let's go with 3/4. Let me zoom in a bit so we can have more space. And let's convert this to a decimal. Now keep in mind, guys, that a fraction is really a division problem. So all you have to do is write it out. The numerator goes inside the box, and the divisor, the denominator, goes outside the box. So this fraction, any fraction, it's really the top number divided by the bottom number. So it's really 3 divided by 4. And in order to convert the fraction, I mean, even if you try to do it and you think, okay, 4 times what will get me 3 without going over? It doesn't work, right? It's not there. 4 times 1 is 4. It's already greater than 3, so it doesn't work. So what we need to do, this is where the decimal comes up. We're going to put a decimal right here and add a 0. That way it looks like 30. Okay, and now we could think, okay, 4 times what will get me close to 30 without going over? Well, 4 times 7 is 28, and that doesn't go over, so that's good. So let's put a 7 up here. But remember, there's now a decimal here, a 0. So this decimal just comes right up, and you have a decimal in front of your 7. And anyways, what is 4 times 7? That's 28. So let's write down 28. And of course, we subtract, in case you guys forgot how to do this long division. 30, take away 28. There's 2 left over. And what do we do to finish off the decimal number? We add a 0. Let's add a 0 right here. And then we drop the 0. That way it looks like 20 now. Okay, so 4 times what will get you close to 20 without going over? That one's easy. 4 times 5 is exactly 20. And of course, when you subtract, you get a remainder of 0, and that's when you know that you're done. So, ladies and gentlemen, we have just converted the fraction 3/4. We converted it to the decimal 0.75. Now, of course, if you have a calculator, you could just get the fraction 3 divided by 4. It'll give you the answer 0.75, actually 0.75, of course. But we need to go beyond calculators. We need to understand how these numbers work. So we need to understand that all fractions are really division problems. And if you set up the division problem and do the long division, you'll be able to convert it to a decimal. So 3/4 is really 0.75. Okay. So we converted a fraction to a decimal. And now let's convert this decimal to a percent. I'm just going to explain how to do it. It's really easy. And then we'll get to the how or why that's the case. So 0.75, if I want to convert that to a percent, all I have to do is move the decimal place over 1, 2 spaces. So my answer will be 75%. You could put the decimal there if you want, or 75.0%, but it's really unnecessary. You're just going to leave it as 75%. So let's do another one of these guys. Let's go with the, let's say 1/4. That's common. 1/4 of a tank of gas, 1/4 of a pizza. Let's say I wanted to convert that to a decimal. Of course, a calculator would do it for you, but let's really show our work here how to do this. The top number goes inside, and the bottom number, the divisor, goes outside. And of course, 4 times what gets you close to 1 without going over. You can't do that. So that is why we put a point right here and a 0, so it looks like 10. And of course, the decimal is just going to come right up to the top, and you put the decimal right there. Now let's think, 4 times what gives us something close to 10 without going over? 4 times 2 gets us close to 10. That's 8. And if I subtract, I'll have a 2. And then, of course, we add a 0 and then drop a 0, so that's 20. 4 times 5 is 20, and we're done. So we have converted 1/4 to a decimal, 0.25. Okay. Now, if they asked you to take your decimal and convert it to a percent, 0.25 converted to a percent, that's easy. All you have to do is move it over 2 spaces. 1, 2. Okay. So we're going to convert it to a percent, and that becomes 25%. So any decimal to any percent is really easy. Let me come up with something totally random. Let's say 0.385. That's totally random. And let's convert that to a percent. Okay, a percent is going to go 1, 2 spaces that way. So your percent will be 38.5%, 38.5%. Okay. Let's do another one. Oh, by the way, that's this next section right here, converting a decimal to a percent. So converting a decimal to a percent, let's come up with something like 1.1. How's that? Let's convert the decimal 1.1 to a percent. Well, we said all we have to do to convert it to a percent is to move it over 2 spaces. So you'd really have 1 with a 1, and then that extra space is a 0. So that'd be 110%. And that kind of reminds me of, like, you know, when they say, yeah, I tried really hard on something. Well, how much effort did he put in? I put in 110%. Okay, guys, that's impossible. You can't really give something 110% because you are only one whole person. So if you give everything you got, that would be 100%, which is one whole. But 110%, that doesn't really make sense if you're talking about your effort, because that would mean 1.1, that there's a little bit more of you somewhere else, right? So 1.1 as a percent is 110%. 100% would be one whole, but since it's 1.1, it's a little bit more than one whole. That's why as a percent, it comes out to as 110%. Anyway, we could also, what else could we ask? We could ask you to convert a percent to a fraction. And that's, like, honestly the easiest thing to do ever. Because when you convert a percent to a fraction, if we just understand what the word percent means, it really means per cent, and cent means 100, so that really means per 100. The word cent means 100. How many years are in a century? 100 years. How many cents are in a dollar? 100 cents are in a dollar. How many centimeters are there in a meter? 100. So if you understand the word percent, you'll understand that that means per 100. And if you do have any type of percent, like let's say 75%, and you want to change that to a fraction, that simply means 75 per 100. So that is your fraction. And of course, if you could reduce it, you should. So right here, 75, you could reduce by 25, so that would reduce down to 3/4. So any percent that you have, like let's say 13%, you want to rewrite it as a fraction, that'll simply be 13 over 100, because percent means per 100. And of course, 13 over 100, you cannot reduce, so that's it. Let's move on. Up here, this next portion of our handout, of our notes, we talk about perfect square numbers, and we already talked about perfect square numbers yesterday on the previous video, previous lesson. We know that 2 squared is 4, 3 squared is 9, 4 times 4, 5 times 5. That's why we call these perfect square numbers. And we also talked about taking the square root of a perfect square number, that the answer is a perfect answer, a nice natural answer. So the square root of 25 is 5, the square root of 121 is 11, the square root of 49 is 7. Now, if I ask you something like the square root of 50, then that would definitely be an irrational number. If you type in the square root of 50 on a calculator, it'll give you a crazy infinite decimal that doesn't repeat, it has no pattern. But what we're going to learn on this section is how to give a decimal approximation. So let's go over here to the side. Let me just write down the square root of 50. Even though it's an irrational decimal, an irrational number, we could give a decimal approximation. Now, of course, if you did it on a calculator, it'd be simple. It would do it for you. But in this case, the square root of 50 I know is a little bit more than the square root of 49. So the square root of 49, we already know is 7. So the square root of 50 must be a little bit more than the square root of 49. So that would be 7.1 as an approximation. It's close to 7.1. It's not exact. Let me tell you exactly what the square root of 50 is right here on a calculator. The square root of 50 is 7.071067812, and it continues forever and there's no pattern. But a good approximation would be about 7.1. Okay? So we're going to learn how to give decimal approximations by being able to create this perfect square number list, and also being able to see where our certain numbers fall between. So check this out. This example I give you, the square root of 91. Okay, well, square root of 91, we know it's irrational. On a calculator, it's going to be a crazy decimal that continues forever. There is no pattern. It's irrational. However, if we want to give a decimal approximation, is it about 9 point something, or is it 10 point something? We need to understand this list. Let's go to where 91 would fall. 91 is almost perfectly between 81 and 100. 91 is definitely in between. So it's not a little bit more than the square root of 81, and it's not a little bit less than the square root of 100. It's almost perfectly in between the answer, square root of 81, and the square root of 100. So the square root of 81 is 9, the square root of 100 is 10. So the square root of 91 must be pretty much between the answers 9 and 10. So a good decimal approximation would be 9.5, in between the answer 9 and the answer 10, 9.5. Now, if I would have asked for the square root of 82, then that's just a little bit more than the square root of 81, which is 9. So that would be about 9.1. So let's practice by taking this number that they're asking us to do the square root of and seeing where it falls in terms of this perfect square number list. So 26, is it less than the square root of 25? Is it more than the square root of 25? Is it perfectly in between 25 and 36, or is it just a little bit more than 25? So 26 is just a little bit more than 25. So if the square root of 25 is 5, then the square root of 26 must be a little bit more than 5. So what we're going to do is put the little squiggly lines right here, and we're going to put a little bit more than 5. That's going to be 5.1. Okay. The square root of 80. Where is 80 at? Well, 80 is really close to the square root of 81. So how close is it, and where is it? Is it right below? Is it right above? Is it kind of in between the two numbers here? Well, 80 is right below 81. So if the answer to the square root of 81 is 9, that means that the approximation of the square root of 80 is a little bit less than 9. So that'd be about 8.9. So right here, we're going to put the squiggly lines that mean approximation, and we're going to put 8.9. Now, if I would have asked for the square root of 82, then it would be a little bit more than the square root of 81, so that would be about 9.1, right? Let's go to the square root of 111. Where's 111 at? Is it just a little bit more than 100? Is it just a little bit less than 121? Or is it almost perfectly in between 100 and 121? As you can see, 111 is almost perfectly between 100 and 121. So if the answer to the square root of 100 is 10, and the square root of 121 is 11, and if you're doing the square root of 111, which is between the answer 10 and the answer 11, then that must be about 10.5. That'd be a good decimal approximation. 10.5. Now, of course, if I actually did it on a calculator, it would be an irrational decimal that continues on forever with no pattern. I might as well do that right now on a calculator. If I did the square root of 111, that'll give me 10.5356537.5, and it continues. But as you can see, 10.5 is really a good approximation. How about the square root of 48? Where does 48 land in terms of these perfect square numbers? 48 is right below 49. So what's the answer to the square root of 49? 7. So this answer must be right below the answer 7, which would be about 6.9. So we're going to put the approximation symbol and then 6.9. And that's how we do decimal approximations. We write the perfect square number list, and then we see where it lands. So if I asked you, what's the square root of 101? Oh, well, 101 is a little bit more than 100, so the square root of 100 is 10, so the square root of 101 must be 10.1. That's how we do it, by understanding these numbers and seeing where it lands, and we give a decimal approximation. So all of this stuff that we've covered, all of this is going to be on the back side of this handout, which is the second homework assignment that we're going to be doing in this class. So here is the back side, and I'll tell you this, just for the sake of time, let's not do everything on the back side. Let's just do the left column, and also this part down here, this arranging numbers from least to greatest. That's a fun problem. Let's do that one. But for homework, let's not worry about, and check this out, I want to put it as a highlighter. Let's not worry about this. You could do it if you want, and I recommend you to practice and try to do it. I mean, a lot of it's pretty easy, like convert the percent to a decimal. Okay, you have to change that to a fraction first, 3 over 100, and then divide 3 by 100. But anyways, we're going to skip over that because we're kind of crunched on time. So let's just focus on classifying real numbers, and let's focus on comparing using the less than, greater than, or equal to. And we should be good from there for what's coming out on the quiz in the future. And here's giving decimal approximations. That's always fun. I recommend making a perfect square number list. And writing percents as fractions. We said that was really easy. So right here, 3 over 100, 15 over 100. Reduce if possible. And over here, this is very fun. List the following real numbers in order from least to greatest. So that is our homework assignment. Maybe I'll make a video explaining every single question on here.